So the second type of stablecoin we're looking at today are the crypto-collateralized stablecoins. Following our taxonomy, right, we have here, for example, DAI, which is a crypto-collateralized stablecoin. We have Liquity, we have SNX, and as we already discussed in the introductory lecture, right, SNX derives its values from endogenous tokens, so tokens that are inside the system, inside the model. And while DAI, for example, is its value is derived from an exogenous. It's an exogenous model, for example, from ETH that's collateralized in the DAI smart contracts. Now, let's briefly recapitulate how DAI works, as we've already mentioned in the lending and borrowing lecture. So what we typically do is we generate a vault by minting. We take Ether, right, which we collateralized in the smart contract, and then this allows us to mint DAI in a second step to generate DAI, because we already have some collateral in the smart contracts, and this causes us to have some debt. And now in the last case, steps 3, if we want to pay back DAI into the smart contract, we can redeem the Ether, we can get the Ether back that we collateralized in the vault. Now, we can use any approved Ethereum asset as a collateral in MakerDAO, and so it's rather flexible nowadays. The collateralization ratio is rather hefty, 150%, which is non-negligible and determines obviously the efficiency of your debt position. And what's interesting is DAI is not an algorithmic stablecoin, right? The value of the DAI depends here solely on the collateral that is being collateralized. And naturally, the collateral can be volatile, and the debt position may need to be topped up if they become unhealthy, as we've discussed in the lending and borrowing lecture. A second example of crypto-collateralized stablecoin is Liquity. Liquity operates similar to DAI, but has a few differences. So in the first step, you collateralize, for example, Ether into a smart contract pool, and then you can redeem LUSD out of this pool, right? And similarly, you can, when you pay back LUSD to the contract, you can redeem Ether at face value. And this can be done instantaneously, and there's a redemption fee that's charged on each redemption by user. So what people have done, and why Liquity was quite or still quite popular, is they could collateralize Ether, right? So you put Ether into the contract, you get LUSD. The LUSD, you exchange it on the secondary market back to Ether, which you then again collateralize, right? And this allows you to get increased exposure to Ether with naturally the associated risks that this entails. So always, as again, anything in this lecture is no financial advice. Be careful with leverage. You may lose your positions very quickly, but it may also allow you to gain increased exposure to a particular asset that you're interested in. What's interesting here is you don't need any outside protocol for leverage, right? And the Ether price in Liquity is always determined with an external price oracle. Okay, so one other specificity here is that the collateralization ratio is only 110%. So this makes the such protocol compared to DAI more capital efficient, because we need less collateral in general. But it may also aggravate liquidations. I have not seen any quantitative measurement on this, but maybe you would like to investigate what are the quantitative drawbacks on having a lower collateralization ratio, and what this entails in terms of liquidation risks and liquidation spirals. So that looks like very interesting future work maybe for you. Okay, so one more point on Liquity that I wanted to mention. If you go into the smart contract, Liquity smart contract, what you will see, and what's rather interesting, is that there's a certain type of compensation that's being paid to liquidators, in particular to compensate for the gas that liquidators pay. So I found this an interesting design choice. You may want to check out yourself how efficient that is and how the gas is calculated, right? I mean, how does the Liquity smart contract calculate how much needs to be paid back? And yeah, so this might be an interesting exercise for you. Finally, let's just compare DAI and Liquity LUSD on just their price, really. Bear in mind here that the y-axis is almost the same, but not exactly the same. So we can see in both a certain type of volatility. It seems like at some periods LUSD was a bit more volatile, then it became a bit less volatile. So there's nothing really too much of a constant in these stablecoins. If we look at the price chart, at least they do appear to be rather volatile. DAI maybe more stable overall. I'm not sure. Yeah, but it seems like the overall the stablecoins are definitely not always stable. The volatility in LUSD could be explained with the possibility of a higher leverage there than in DAI, due to the lower collateralization factor. But this is just my speculation, so I leave it up to you to explore. So thank you so much for your interest in this lecture. I hope it kind of gave you a sense of how crypto-collateralized stablecoins operate. Maybe you would want to design your own. Try to play with various design parameters such as the collateralization ratio, the way how liquidators get compensated or not, the way how liquidations work at all in general. You might want to innovate on that front, etc.